To determine the appropriate installation method for the 240-volt welder, several factors must be considered, including conductor sizing, overcurrent protection, and compliance with the National Electrical Code, specifically Article 630 and Section 210.21b. Firstly, let's address the branch circuit ampacity. The calculation provided 200% times 35 amps equals 70 amps. This is the calculated minimum ampacity required for the branch circuit conductors based on the welder's input current and duty cycle. Secondly, the maximum breaker size should be 70 amps. This is intended to protect the branch circuit conductors and the welder itself from overcurrent conditions. Moving on to conductor selection. Number 8 THHN copper conductors have an ampacity of 40 amps at 75 degrees Celsius. This is a crucial detail, as the conductors must be rated for at least the minimum branch circuit ampacity calculated earlier. It is important to verify the temperature rating of the terminations at both ends of the conductor to ensure compatibility and safety. Regarding the receptacle and plug, 6-50p receptacle and matching plug are rated for circuits not exceeding 50 amps. This is a key limitation to consider, as the calculated branch circuit ampacity is 70 amps. Article 630.11 requires a disconnecting means and overcurrent protection for arc welders. This ensures that the welder can be safely disconnected from the power source for maintenance or in case of an emergency. Article 630.12b allows the branch circuit conductors to be smaller than the service conductors. This is an important provision, as it allows for a more economical installation without compromising safety. Section 210.21b exception number 2 allows for the use of a cord and plug for equipment over 600 volts, nominal, provided that the ampacity of the cord is not less than the ampacity of the branch circuit conductors. This exception is relevant because it addresses the specific scenario of using a cord and plug connection for the welder. In conclusion, the proposed circuit design meets the requirements of Article 630 and 210.21b exception number 2. Number 8 THHN copper conductors and PVC conduit are acceptable for the branch circuit conductors provided they are protected by a 70 amp overcurrent protective device. However, a 6-50p receptacle and plug are not suitable for the 70 amp circuit, as they are only rated for 50 amps. Therefore, a receptacle and plug with a higher ampacity rating, such as a 6-70p, would be required to comply with the code. A 70 amp overcurrent protective device, also known as an OCT, is required to protect the branch circuit conductors and the welder from overcurrent conditions. To summarize, firstly, calculate the minimum branch circuit ampacity based on the welder's input current and duty cycle. In this case, it is 70 amps. Secondly, select conductors with an ampacity rating equal to or greater than the calculated branch circuit ampacity. Number 8 THHN copper conductors with an ampacity of 40 amps at 75 degrees Celsius are acceptable, provided the termination points are also rated for 75 degrees Celsius. Thirdly, choose a receptacle and plug with an ampacity rating equal to or greater than the branch circuit ampacity. A 6-50p receptacle and plug are not suitable, as they are only rated for 50 amps. A receptacle and plug with a higher ampacity rating, such as a 6-70p, would be required. Fourthly, install a 70 amp overcurrent protective device to protect the branch circuit conductors and the welder from overcurrent conditions. Fifthly, ensure that all wiring and connections comply with the National Electrical Code, specifically Article 630 and Section 210.21b. Another important consideration is the proper grounding of the welder. The grounding conductor should be sized according to the overcurrent protective device rating as specified in an EC Table 250.122. The grounding conductor should be connected to the welder frame and to the grounding terminal in the receptacle. It is also important to ensure that the welder is properly bonded to the building's grounding system. This can be achieved by connecting a bonding jumper from the welder frame to a nearby metal water pipe or to the building's grounding electrode system. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of the welder. Furthermore, it is crucial to follow the manufacturer's instructions for installing and operating the welder. The manufacturer's instructions may provide additional information and recommendations that are not covered in the National Electrical Code. For example, the manufacturer's instructions may specify the type of cord and plug to use, the recommended wire size for the branch circuit conductors, and the proper settings for the welder's controls. It is also important to inspect the welder regularly for any signs of damage or wear. If any problems are detected, the welder should be repaired by a qualified technician before being used again. Regular maintenance and inspection can help to prevent accidents and ensure the safer and reliable operation of the welder. In addition to the technical aspects of the installation, it is also important to consider the location of the welder and the surrounding environment. The welder should be located in a well-ventilated area to prevent the accumulation of fumes and gases. The area around the welder should be kept clear of flammable materials to prevent fires. The welder should also be protected from moisture and other environmental hazards. If the welder is located outdoors, it should be protected from rain and snow. If the welder is located in a damp or wet environment, it should be grounded with extra care. The specific requirements for the location of the welder may vary depending on the local electrical codes and regulations. It is important to consult with a qualified electrician to ensure that the installation complies with all applicable requirements. Another important consideration is the type of welding process that will be used with the welder. Different welding processes require different voltage and current levels. The branch circuit conductors and overcurrent protective device should be sized accordingly. For example, shielded metal arc welding, also known as stick welding, typically requires a lower voltage and higher current than gas metal arc welding, also known as MIG welding. The welder's output voltage and current should be matched to the welding process being used to ensure optimal performance and safety. It is also important to consider the duty cycle of the welder. The duty cycle is the percentage of time that the welder can be operated at its rated output current without overheating. Welders with a lower duty cycle may require a larger branch circuit to dissipate the heat generated during welding. The welder's duty cycle should be taken into account when sizing the branch circuit conductors and overcurrent protective device. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed when installing a welder. For example, the Occupational Safety and Health Administration, also known as OSHA, has regulations regarding the safe use of welding equipment. These regulations cover topics such as personal protective equipment, ventilation, and fire prevention. It is important to be familiar with and comply with all applicable codes and standards to ensure a safe and compliant installation. Finally, it is always a good idea to consult with a qualified electrician before installing any electrical equipment, including a welder. A qualified electrician can assess the specific requirements of the installation and provide expert advice on the best way to proceed. They can also ensure that the installation complies with all applicable codes and regulations. Hiring a qualified electrician can help to prevent accidents and ensure the safe and reliable operation of the welder. To reiterate the key points, firstly, determine the welder's input current and duty cycle. Secondly, calculate the minimum branch circuit ampacity based on the welder's input current and duty cycle. Thirdly, select conductors with an ampacity rating equal to or greater than the calculated branch circuit ampacity considering the termination temperature ratings. Fourthly, choose a receptacle and plug with an ampacity rating equal to or greater than the branch circuit ampacity. Fifthly, install an overcurrent protective device with a rating that does not exceed the ampacity of the conductors. Sixthly, ensure proper grounding and bonding of the welder. Seventhly, follow the manufacturer's instructions for installation and operation. Eighthly, consider the location of the welder and the surrounding environment. Ninthly, consider the type of welding process that will be used with the welder. Tenthly, consult with a qualified electrician before installing any electrical equipment. By following these steps, you can ensure a safe and compliant installation of the 240-volt welder. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Incorrect electrical work can be dangerous and may result in serious injury or property damage. Remember to always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment such as safety glasses and gloves. Follow all applicable codes and regulations. And if you are not comfortable performing electrical work, hire a qualified electrician. Safety should always be the top priority when working with electricity. Consider the potential for voltage drop in the branch circuit. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause the welder to operate inefficiently and may even damage the equipment. The amount of voltage drop in a branch circuit depends on the length of the circuit, the size of the conductors, and the amount of current flowing through the circuit. To minimize voltage drop, use larger conductors and keep the circuit as short as possible. The National Electrical Code provides guidelines for calculating voltage drop in branch circuits. It is important to calculate the voltage drop in the branch circuit to ensure that it is within acceptable limits. Also, consider the impact of harmonics on the branch circuit. Harmonics are distortions in the electrical waveform that can be caused by nonlinear loads, such as welders. Harmonics can cause overheating of conductors and equipment, and may also interfere with the operation of other electrical devices. To mitigate the effects of harmonics, use harmonic filters or reactors. The National Electrical Code provides guidelines for dealing with harmonics in electrical systems. It is important to consider the potential impact of harmonics on the branch circuit and take appropriate measures to mitigate their effects. It is crucial to select the correct type of cord for the welder. The cord should be rated for the voltage and current required by the welder. It should also be flexible and durable enough to withstand the rigors of welding. The National Electrical Code specifies the types of cords that are permitted for use with welding equipment. Use only cords that are listed and labeled for the intended application. Avoid using extension cords if possible, as they can cause voltage drop and may not be rated for the current required by the welder. If an extension cord is necessary, use a heavy-duty cord that is rated for the voltage and current required by the welder. Ensure that the extension cord is properly grounded. Also, the selection of the overcurrent protection is crucial. The overcurrent protective device should be sized to protect the branch circuit conductors and the welder from overcurrent conditions. The National Electrical Code specifies the maximum size of the overcurrent protective device that is permitted for use with welding equipment. Use only fuses or circuit breakers that are listed and labeled for the intended application. Avoid using overcurrent protective devices that are too large, as they may not provide adequate protection. Also, avoid using overcurrent protective devices that are too small, as they may trip unnecessarily. Finally, it is very important to follow the manufacturer's recommendations for the installation and operation of the welder. The manufacturer's recommendations may provide additional information that is not covered in the National Electrical Code. Follow all safety precautions and warnings. If you are not comfortable installing or operating the welder, consult with a qualified electrician. Welding can be a dangerous activity, so it is important to take all necessary precautions to ensure your safety. And always remember to disconnect the power supply before performing any maintenance or repairs on the welder. This will help to prevent electrical shock and other hazards. Regular maintenance and inspection of the welder can help to ensure its safe and reliable operation.